players go round and round, okay, and when the music stops they sit. That's how a circular cue works. It loops, okay. Means suppose the in a musical chair there is a chair like a first one, second one, third one, and again fourth, and so on, okay. So this chair and players go round to round and round, okay. So that's how a circular cue works, like it in loops. A circular cue is a type of a cue in which last position connects back to the first position, forming a circle. So last element is connected to the first element and forming a circle, okay. So it overcomes the problem of wasted space in simple linear cue, okay, with wasted spaces. It overcomes means in a linear queue the most of the spaces are wasted, but in circular queue these are not chance to wasted. So slide 2, why circular queue and problem in a linear queue. Means why you prepare for a circular queue rather than a linear queue. In a linear queue, once the rear reaches once the rear reaches the end, we can't insert more element, okay. So suppose these are the linear queue. So if you reaches end, suppose you reach here end, so even if there if spaces at the front, suppose you nq push nq1, then 2 and 3 and again 4, and you dq, suppose you push 1 2 3 4 and again dq. So in a linear queue, in queue there is a principle is a first in first out. So first pop is a 1, okay. So here are the spaces, here's empty seats, okay, empty space at the front, but you can't add any push element. Here is a, even if there is an empty space, but you can't add. It's a, like a, if okay, it's like a bus with empty seats at the front, but the conductor says bus full because the entry is at the back, waist full, right. So example, here index is a 0 1 2 3 4, q is a abc, front, now front is a 2 and rear is a 4. Now even if we delete ABC, we cannot insert new element because rear is at a less. Means in ABC, suppose suppose we deleted A or B, suppose we deleted A. Here is an empty space, but you can't add, cannot insert new element because now rear is a last. So you can't add any element. Okay. This wastes memory, so that's why circular queue. Okay. Now slide 3, a circular queue solution. In a circular queue, when a rear reaches the last index, it wraps around to 0. When a rear reaches the last index, it wraps around to 0. Space is reused. Okay. Circular queue solves this linear queue problem. When the rear reaches the end, it wraps around the front like a Ferris wheel. The seats rotate. A new passenger can hop on a wheel where space is available. There, here is a circle. So element to push element, again push element, again push element, and so on. Okay. So now this one is our front element and this is our rear element. If you remove pop front element, then here is an empty space and you can add any element. Okay. Now how circular cube representation. Here front is a points to the first element, rear is a points to the last element. Initially front equal to -1 and rear equal to -1. If front equal to -1 and rear equal to -1 means this queue is a empty. Okay. Now circular queue operations with a visualization. With the help of visualization you can understand easily. Check if queue is empty. So if you want to check queue is empty or not, so front equal to -1 you can use. Okay. So else check if queue is a full, then rear plus 1 equal to front, yeah, rear equal to size -1. Okay, either and front equal to 0 means you use front equal to 0 or rear equal to size minus or rear plus 1 equal to front. Okay, so now insert operations in queue. Insert means with the in queue, everyone know, or you can in queue the element from a rear side. Suppose we want to add, insert the element. Okay, so we check if empty, check if full. If suppose your NQ means your queue is a full, you cannot add any element. Okay, so if empty you can add element. Front equal to rear equal to front equal to rear equal to 0. Else rear plus 1 mod size means go index number 0, because 0 is a front element, you can remove all element. Okay, it's all about in visualization. Insert element and queue rear. So now visualization. Suppose empty queue means our front and rear at position -1. In a empty queue, our front and rear is a -1. Okay, insert 10, first 10. Now front is our 0 because front plus plus. First -1 plus 1 equal to 0. So now front equal to 0 and rear equal to 0. Now insert 20. Insert 20 but front is our 0. Okay, rear plus plus. Rear is a -1 now rear is a 0. 0 plus 1 is a 1. Okay, now insert 30. Front is 0 and rear is a 0 1 2. Okay, wrap around. Rear is a last index. Suppose insert next. Rear is a last index. Suppose here is a 2. You insert 10, 20 and 30, and now your queue is a full. So you can use insert next. Rear is at a last index. Rear 2 plus 1 mod 4. 4 means size of an array. Okay, so after filling 10, 20, 30 and then 40. Now front is a 0 and rear is a 3. 0, 1, 2, 3. Okay. If now we delete some elements and insert new one, rear will rotate to front. Delete operation. Suppose a delete operation in our DQ. Check if empty. If their queue is empty, so you can't add. You can't delete any element. Okay. So in this animation you can see, suppose we push suppose 2 in queue, so it's a front. Okay, now front element is 2, again I include 2. Suppose I change, suppose I push 5, so it's now 5 is a front is a 2 and 5 is a rear. Now I push now 8, so here NQ, again 8, again 8, now 9 is, so in this type. Suppose DQ, DQ means it's a remove front element. Here is front element is a 2, if you DQ, so 2 is a DQ. Okay, so you can add here element. Now you add 3 NQ, again 3. Suppose again 3, it's not allowed because of the overflow. Q is a, now Q is a 4. Okay, it's like this is a linear queue. Now what is a circular queue? So in circular queue, suppose we push 3 in queue. Now 3 is a front, and front is 3 and also rear is a 3. Okay, so now 5, push 5 again, push 2, again push 2. Now push 1, push 5, push 7 and push it. Okay, so now front is our 3 and rear is our 6. Okay, so now DQ means in a queue first in first out, so DQ is the 3 is the DQ. Okay, now I can push element. Now Q is a full. You can DQ element 1, 2, 3 again. This is a circular queue. So again 6. Again this queue is not stopped. They are again and again run. When until the queue is a full. Okay, you can push element in queue, in queue, and in queue. Okay. Also, this is a circular queue, and there is a difference between the linear queue and circular queue. That's it for today. Video less like, please like, share, and subscribe our YouTube channel. Thank you.